Hey everyone, so in this video we are going to talk about an article which I think is published at the same time when DynamoDB was released. You see, Amazon DynamoDB, a fast and scalable NoSQL database service designed for internet scale applications, was published on January 18, 2012. Today is very exciting day as we released Amazon DynamoDB, a fast, highly scalable and reliable cost-effective NoSQL database service designed for internet scale applications. Dynamo is the result of 15 years of learning in the areas of large scale non-relational database and cloud services. Several years ago, we published a paper on the details of Amazon's Dynamo technology. This is the same paper that we read earlier, which was one of the first non-relational database developed at Amazon. The original Dynamo design was based on a core set of strong distributed system principles, resulting in a ultra scalable and highly reliable database systems. Amazon DynamoDB, which is new service, continues to build on these principles and also builds on our years of experience with running non-relational databases and cloud services. And the examples of that are like Amazon SimpleDB and Amazon S3 at scale. It is very gratifying to see all of our learning and experiences become available to our customers in the form of an easy to use managed service. Amazon DynamoDB is a fully managed NoSQL database service that provides fast performance at any scale. Today's web-based applications often encounter database scaling challenges when faced with growth in users, traffic and data. With Amazon DynamoDB, developers scaling cloud-based application can start small with just the capacity they need and then increase the request capacity of a given table as their app grows in popularity. Their tables can also grow without limits as their users store increasing amounts of data behind the scene. Amazon DynamoDB automatically spreads the data and traffic for a table over a sufficient number of servers to meet the request capacity specified by the customer. Amazon DynamoDB offers low predictable latencies at any scale. Customers can typically achieve average service side in the single digit millisecond. Amazon DynamoDB stores data on a solid state drives and replicates it synchronously across multiple AWS availability zones in AWS region to provide built-in high availability and data durability. So let's see, next section is history of NoSQL at Amazon Dynamo. So the Amazon.com e-commerce platform consists of hundreds of decoupled services developed and managed in decentralized fashion. Each service encapsulates its own data and presents a hardened API for others to use. Most importantly, direct database access to the data from outside its respective service is not allowed. This architectural pattern was a response to the scaling challenges that had challenged Amazon.com through its first 5 years. When direct database access was one of the major bottlenecks in scaling and operating the business, while a service-oriented architecture addressed the problems of a centralized database architecture, each service was still using traditional data management system. The growth of Amazon's business meant that many of these services need more scalable database solutions. In response, we began to develop a collection of storage and database technologies to address the demanding scalability and reliability requirements of Amazon.com e-commerce platform. We had been pushing the scalability of commercially available technologies to their limits and finally reached a point where these third-party technologies could no longer be used without significant risk. This was not our technology vendors' fault. Amazon's scaling needs were beyond the specs for their technologies, and we were using them in ways that most of their customers were not. A number of outages at the height of the 2004 holiday shopping season can be tracked back to scaling commercial technology beyond their boundaries. So you see here we are talking about, today we are in 2024. We are talking about 2012 here, right? So 20 years back, 10 years back from now. Okay, so Dynamo was born out of their need for a highly reliable, ultra scalable key value database. This non-relational or NoSQL database was targeted at use cases that were core to the Amazon e-commerce operations, such as the shopping cart and session service. Any downtime or performance degradation in these services has an immediate financial impact, and their fault tolerance and performance requirements for the data sources are very strict. These services also require the ability to scale infrastructure incrementally to accommodate growth in request rates or dataset size. Another important requirement for Dynamo was predictability. This is not just predictability of median performance and latency, but also to the end of the distribution, like 99.9 percentile. So we could provide acceptable performance for virtually every customer. To achieve all of these goals, we needed to do groundbreaking work. After the successful launch of the first Dynamo system, we documented our experiences in a paper so others could benefit from them. Since then, several Dynamo clones have been built, and the Dynamo paper has been the basis for several other types of distributed databases. This demonstrates that Amazon is not the only company that needs better tools to meet their database needs. So, and this paper I believe is the same that we read last time, Amazon's DynamoDB, this one, that highly available Amazon's Dynamo highly available key value store. We studied it in the last one. So this paper shows the core principle, explains the core principle behind the DynamoDB. Lessons learned from Amazon's Dynamo. Dynamo has been in use by a number of core services in the e-com platform, and their engineers have been very satisfied by its performance and incremental scalability. However, we never saw much adoption beyond these core services. This was remarkable because although Dynamo was originally built to serve the needs of shopping cart, its design and implementation were much broader and based on input from many other services architects. As we spoke to many senior engineers and service owners, we saw a clear pattern start to emerge in their explanation of why they don't adopt Dynamo more broadly. While Dynamo gave them a system that met their reliability, performance, and scalability needs, it did nothing to reduce the operational complexity of running large database systems. Since they were responsible for running their own Dynamo installation, they had to become experts on the various components running in multiple data centers. Also, they needed to make complex trade-off decisions between consistency, performance, and reliability. This operational complexity was a barrier that kept them from adopting Dynamo. During this period, several other systems appeared in the Amazon ecosystem that did meet their requirements for simplified operational complexity. Notably, Amazon S3 and Amazon SimpleDB. These were built as managed web services that eliminated the operational complexity of managing systems while still providing extremely high durability. Amazon engineers preferred to use these services instead of managing their own databases like Dynamo, even though Dynamo's functionality was better aligned with their application's needs. With Dynamo, we had taken great care to build a system that met the requirements of our engineers. After evaluations, it was obvious that Dynamo was ideal for many databases use cases, but we learned that engineers found the prospect of running a large software systems daunting, and instead looked for less ideal design alternatives that freed them from the burden of managing databases and allowed them to focus on their applications. It became obvious that developers strongly preferred simplicity to fine-grained control as they voted with their feet and adopted cloud-based AWS solutions like S3 and SimpleDB over Dynamo. Dynamo might have been the best technology in the world at the time, but it was still software you had to run yourself, and nobody wanted to learn how to do that if they did not have to. Ultimately, developers wanted a service. History of NoSQL at Amazon. This explains about the SimpleDB. One of the cloud services Amazon developers preferred for their database needs was Amazon SimpleDB. In the 5 years that SimpleDB has been operational, we have learned a lot from its customers. First and foremost, we have learned that a database service that takes away the operational headache of managing distributed system is extremely powerful. Customers like SimpleDB's stable interface and its flexible data model. Not having to update their schemas when their system evolves makes life much easier. However, they most appreciate the fact that SimpleDB just works. It provides multi-data center replication, high availability, and offers rock-solid durability. And yet, customers never need to worry about setting up, configuring, or patching their database. Second, most database workloads do not require the complex query and transaction capabilities of a full-blown relational database. A database service that only presents a table interface with a restricted query set is a very important building block for many developers. While SimpleDB has been successful and powers the applications of many customers, it has some limitations that customers have consistently asked us to address. Domain scaling limits. SimpleDB requires customers to manage their datasets in containers called domains, which have a finite capacity in terms of storage, that is 10 gigabytes, and request throughput. Although many customers worked around SimpleDB's scaling limitation by partitioning their workloads over many domains, this side of SimpleDB is certainly not simple. It also fails to meet the requirement of incremental scalability, something that is critical to many customers looking to adopt a NoSQL solution. Predictability of performance. SimpleDB, in keeping with its goal to be simple, indexes all attributes for each item stored in a domain. While this simplifies the customer experience on schema design and provides query flexibility, it has a negative impact on predictability of performance. For example, every database write needs to update not just the basic record but also all attribute indices, regardless of whether the customer is using all the indices for querying. Similarly, since the domain maintains a large number of indices, its working set does not always fit in memory. This impacts the predictability of domains read latency, particularly as dataset size grows. Consistency. SimpleDB's original implementation had taken the eventual consistent approach to the extreme and presented customers with consistency windows that were up to seconds in duration. This meant that system was not intuitive to use and developers used to a more traditional database solution had trouble adopting it. The SimpleDB team eventually addressed this issue by enabling customers to specify whether a given read operation should be strongly or eventually consistent. Pricing complexity. SimpleDB introduced a very fine-grained pricing dimension called machine hours. Although most customers have eventually learned how to predict their cost, it was not really transparent or simple. Finally comes the DynamoDB. As we thought about how to address the limitation of the SimpleDB and provide one, the most scalable NoSQL solution available, and second, predictable high performance, we realized our goals could not be met with SimpleDB APIs. Some SimpleDB operations require that all data for a domain is on a single server, which prevents us from providing the seamless scalability our customers are demanding. In addition, SimpleDB APIs assume all items attributes are automatically indexed, which limits performance. We concluded that an ideal solution would combine the best parts of the original DynamoDB design, incremental scalability, predictability, high performance, with the best parts of the SimpleDB, ease of administration of a cloud service, consistency, and a table-based data model that is richer than a pure key value store. These architectural discussions culminated into Amazon Dynamo, a new NoSQL service that we are excited to release today. Today means that is this January 2012. Amazon DynamoDB is based on the principle of Dynamo, a progenitor of NoSQL, and brings the power of the cloud to the NoSQL database world. It offers customers a high availability, reliability, incremental scalability with no limits on the dataset size or request throughput for a given table, and it is fast. It runs on the latest in solid state drive technology and incorporates numerous other optimizations to deliver low latency at any scale. Amazon DynamoDB is the result of everything we have learned from building large scale non-relational database for Amazon.com and building highly scalable and reliable cloud computing services at AWS. Amazon DynamoDB is a NoSQL database service that offers the following benefits. It is managed. DynamoDB frees developers from the headaches of providing hardware and software, setting up and configuring a distributed database cluster, and managing ongoing cluster operations. It handles all the complexities of scaling and partitions and repartitions your data over many machines resources to meet your IO performance requirements. It also automatically replicates your data across multiple availability zones and automatically replicates in the case of disk or node failures to meet stringent availability and durability requirements. From our experience of running Amazon, we know that manageability is a critical requirement. We have seen many job postings from companies using NoSQL products that are looking for NoSQL database engineers to help scale their installations. We know from our Amazon experience that once these clusters start growing, managing them becomes the same nightmare that running large RDBMS installations was. Because Amazon DynamoDB is a managed service, you won't need to hire expert to manage your NoSQL installation. Your developers can do it themselves. Scalable. Amazon DynamoDB is designed to scale the resources dedicated to a table to hundreds or even thousands of servers spread over multiple availability zones to meet your storage and throughput requirements. There are no predefined limits to the amount of data each table can store. Developers can store and retrieve any amount of data, and DynamoDB will spread the data across more servers as the amount of data stored in your table grows. Fast. Amazon DynamoDB provides high throughput at very low latency. It is also built on solid state drives to help optimize for high performance even at high scale. Moreover, by not indexing all attributes, the cost of read and write operations is low, as write operations involve updating only the primary key index, thereby reducing the latency of both read and write operations. An application running in EC2 will typically see average server-side latencies in the single-digit millisecond range for a 1 KB object. Most importantly, DynamoDB latencies are predictable. Even as datasets grow, latencies remain stable due to the distributed nature of Dynamo's data placement and request routing algorithms. Durable and highly available, Amazon DynamoDB replicates its data over at least 3 different data centers so that system can continue to operate and serve data even under complex failure scenarios. Flexible. Amazon DynamoDB is an extremely flexible system that does not force its user into a particular data model or a particular consistency model. DynamoDB tables do not have a fixed schema but instead allow each data item to have any number of attributes, including multi-value attributes. Developers can optionally use stronger consistency models when accessing the database, trading off some performance and availability for a simpler model. They can also take advantage of the atomic increment decrement functionality of DynamoDB for counters. Low cost. Amazon Dynamo's pricing is simple and predictable. Storage is $1 per GB per month. Requests are priced based on how much capacity is reserved: $0.01 per hour for every 10 units of write capacity and $0.01 per hour for every 50 units of read capacity. A unit of read capacity equals 1 read per second of capacity for items up to 1 KB in size. If you use eventual consistency reads, you can achieve twice as many reads per second for a given amount of read capacity. Larger items will require additional throughput capacity. In the current release, customers will have the choice of using 2 types of keys for primary key index querying: simple hash keys and composite hash keys, range keys. Simple hash keys gives Dynamo the distributed hash table abstraction. The key is hashed over different partitions to optimize workload distribution. For more background on this, please read the original Dynamo paper that we already have read, like partitioning and sort of thing, how that works. Composite hash key with range key allows the developer to create a primary key that is composite of 2 attributes, a hash key and a range attribute. When querying against a composite key, the hash attribute needs to be uniquely matched, but a range operation can be specified for the range attribute. Example: all our orders from Warner in the past 24 hours. All log entries from server 16 with client's IP address on subnet this one. Performance predictability in DynamoDB. In addition to taking the best ideas of Dynamo and SimpleDB, we have added new functionality to provide even greater performance predictability. Cloud-based systems have invented solutions to ensure fairness and present their customers with uniform performance so that no burst load from any customer should adversely impact others. This is a great approach and makes for many happy customers, but often does not give a single customer the ability to ask for higher throughput if they need it. As satisfied as engineers can be with the simplicity of cloud-based solutions, they would love to specify the request throughput they need and let the system reconfigure itself to meet their requirements. Without this ability, engineers often have to carefully manage caching system to ensure they can achieve low latency and predictable performance as their workload scales. This introduces complexity that takes away some of the simplicity of using cloud-based solutions. The number of applications that need this type of performance predictability is increasing. Online gaming, social graph applications, online advertising, and real-time analytics, to name a few. AWS customers are building increasingly sophisticated applications that could benefit from a database that can give them fast, predictable performance that exactly matches their needs. Amazon DynamoDB's answer to this problem is provision throughput. Customers can now specify the request throughput capacity they require for a given table. Behind the scene, DynamoDB will allocate sufficient resources to the table to predictably achieve this throughput with low latency performance. Throughput reservations are elastic, so customers can increase or decrease the throughput capacity of a table on demand using the AWS Management Console or DynamoDB APIs. CloudWatch metrics enable customers to make informed decisions about the right amount of throughput to dedicate to a particular table. Customers using the service tells us that it enables them to achieve the appropriate amount of control over scaling and performance while maintaining simplicity. Rather than adding server infrastructure and repartitioning their data, they simply change a value in the management console and Dynamo takes care of the rest. Summary: DynamoDB is designed to maintain predictable high performance and to be highly cost efficient for workloads at any scale. From the smallest to the largest internet scale applications, you can get started with DynamoDB using a free tier that enables 40 million of requests per month free of charge. Additional request capacity is priced at cost efficiently hours rates as low as $0.01 per hour for 10 units of write capacity or 50 strongly consistent units of read capacity. If you use eventual consistency reads, you can get twice the throughput at the same cost on the same read throughput at half the cost. Also, replicated solid state drive storage is $1 per GB per month. Our low request pricing is designed to meet the needs of typical database workload that perform large number of reads and writes against every GB of data stored. So this is to learn more about this one. This is the link, developer guide. You can go ahead and check this out. I'll put this link in the description box itself as always. I'll see you in the next video. So the next one, I'm going to read about this paper, distributed transactions at scale in Amazon DynamoDB, this one. So see you in the next one. Bye bye.